Welcome back students. In this video we are reviewing physics quiz based on magnetic effect of current. Let's start it. So first question says that in a hydrogen atom the electron is making this much revolutions per second, frequency is given to you, the radius of the orbit is given, they are asking what is magnetic field produced center. Okay, so this is a very simple question. Some charge is moving in a circular path of some radius what is the magnetic field produced center. Okay, I told you many format. I told you like current format, charge and time format, charge and frequency format, angular frequency format, velocity format, all this format, right? Yeah, so magnetic field simplest formula is what? Mu naught I upon what? 2r, right? Just like a current flowing through a circular loop, what is the magnetic field at the center, right? Same as what? Charge flowing in a circular path, what is the magnetic field produced due to this at the center. So here just current you have to replace current, you can write Q by T or you can write Q into nu. So many format I discussed in classroom right now. So here you need frequency, is the frequency mode, charge into frequency is what your current. Okay, so magnetic field is what? Mu naught charge into frequency upon 2r. Let's put all the values. So mu naught is 4 pi into 10 power minus 7 into charge is 1.6 into 10 power minus 9. Frequency is given to you as 6.6 into 10 power 15 divided by 2 times of radius 0.53 into 10 power what? Minus 10. Okay, let's simplify this. 0.5 into 2 is what? 1. Yes, minus 10 goes up, become plus 10 plus 10 plus 8 is 25 and this becomes what? Minus 6. So 10 power minus 1 is remaining. Okay, yes, like 4 pi means around 12 because 3 pi is what? 3 point something, 12. So you can write 1.2, 1.2, 1.6 and 6 means around 10. So answer is around 10. So you see option is given at 12.5. So what is correct answer of this? 12.5 Tesla approximately. Okay, second question. They said a figure is given, a wire is given and it's producing some current. They said what is magnetic field by this wire at a point P. So a finite wire is given, limited length. Two type of questions we have to discuss in classroom. One is called finite wire, one is called infinite long wire. Infinite long wire is simple question. So finite means we need angles, right? So this is a wire given of length L and they given a point here, right? Now, which also a distance L, right? They are asking what is magnetic field at this point. So what is the angle with this end? 0 degree. What is the angle with this end? Obviously this will be 45 degree. Why? Because this is L, right? So this become what? 45 degree, right? Just like a diagonal of a square. Okay, so this angle 45, then what is formula? Complete formula magnetic field due to finite wire is mu naught I upon 4 pi r sin theta 1 plus sin theta 2. So 1 sin theta with this end is what? 0, that end is what? 45. So mu naught I upon 4 pi r and sin theta 45 is what? 1 by root 2. So that's your answer. So this is given in what? Your third option. Charles is the correct answer. Means there are what you can do, multiply by root 2, divide by root, you get root 2 mu naught I upon what? 8 pi r. That's your answer, right? So they have written in what? Second option. Okay, moving to question number 3, and they said a winding wire which is used to frame a solenoid can bear a maximum current given, length of the solenoid given, is cross section area is radius is given to you, then they are asking what is the required length of the winding and magnetic field also given. Look here, what is magnetic field produced by solenoid? You know, formula is mu naught small ni, or you write mu naught capital Ni by L, right? Correct. So here they are asking what is the total length of the wire required. You know the solenoid look like this one, right? It has many circular turns. Radius of one turn is given to us, so you can find length of one turn, that's become 2 pi r. Then we need to know total number of turns because they are asking what is the total length of this wire. So what is the length of one turn? That's 2 pi r. And if you know number of turns, then you can find total length. So here what is unknown? Number of the turns. Let's find number of turns first. N is what? Actually B into L upon what? Mu naught into what? I. Look here, magnetic field is given to you. How much given? 0.2 Tesla. Okay, length is also given 80 centimeter, 80 into 10 power minus 2 or 0.8 you can write. Mu naught is 4 pi into 10 power minus 7 into what remaining current. Current is also given to what? 10 ampere. Okay. So suppose you simplify these numbers, then what you will get? 0.2 into 4, that okay, you can cancel here, 10 power 1 goes here, so 10 power goes here, 10 power 3, so 1 0 goes here, so you get like 16 means 4 by pi into 10 power 5. This is the number of the turn we are getting. Okay, now what do you do? They are asking total length. Total length is what? Length of one turn is 2 pi r into what? Total number of turn. This will give you total length of that wire required to make that solenoid. Okay, So 2 pi, radius is given to you. How much radius given? Is given as what? 3 centimeters. So 3 into 10 power minus 2 into number of turn is 4 by pi into 10 power 5. So you can cancel this number. So when you cancel this number, your answer is coming what? 2.4 into 10 power what? 3. Okay, this is your correct answer, Charlie. Third option is the answer. Okay, moving to question number 4. And question number 4, they said the wire is given and the dimensions are given, is placed inside a magnetic field of 5 Tesla and current flowing through is given 10 ampere. They are asking what is the net experience by this. So it's very simple question. One wire of this shape is given, right? Yes. They are asking what is net force on this. This is given 4 centimeter, that's given 4 centimeter, and this is given 6 centimeter. So we know that force on a wire is what? BIL, right? L is what? The shortest length of that wire, end to end. We're starting from this end and this end. What is shortest length? You draw a straight line here. That's your shortest length, correct? So see in this triangle, what is that length? 4 centimeter, this becomes 3 centimeter, half of that, so this becomes 5 centimeter. Exactly same way, this triangle 4 centimeter, this is 3 centimeter, that becomes what? 5 centimeter. Means length becomes what? 10 centimeter from this end to that end, correct? Okay, so what is force? Force is what? BIL, or so magnetic field, current, all are given to you. Magnetic field is given 5 Tesla, current is given 10 ampere, right? And length is given 10 centimeters, 10 into 10 power minus 2. You can cancel all this. So force is coming what? 5 Newton. Okay, 5 Newton means what? Second option is the correct answer. Okay, moving to question number 5. A particle is having a charge of 10 microcoulomb and mass of 1 microcoulomb moves in a circular path of radius given and magnetic field also given 0.1 Tesla. When particle is at point P, the uniform electric field is switched on so that the particle start moving along a tangent with the uniform velocity. The electric field is what? So velocity given to you and magnetic field given, they are asking what's electric field, correct na? So look, we know the velocity is equal to what? Electric field by what? Magnetic field. This is given to you. This they are asking. So what we need? We need what? Velocity. So let's find first velocity. Radius is equal to what? mv upon what? Qb, right? Correct? Yes. So let's find velocity from here. Or you can replace directly also if you want. Okay, we need velocity. So velocity is what? QBR by what? M. Let's replace here. We want to find electric field. Electric field is what? Velocity into magnetic field. This is a velocity. QB. So B becomes B square R by what? M. That's simply what your electric field, right? All values are given. So who is this? This is given was a charge of 10 microcoulomb. 10 into 10 power minus 6. Magnetic field is given to us 0.1 into 0.1. Radius is also given as what? 10 centimeter is what? 0.1 meter divided by mass. So mass is given 1 microgram. 1 microgram is 10 power minus 6. Gram is 10 power what? Minus 3. 1 microgram is given. Micro is this much, then gram. So this much kg. Okay. So this directly goes here, right? Minus 3 goes up. You get cancel what here? Correct. So we are getting this answer what? Simply 10 remaining, right? 10 volt per meter. That's your answer, which is given what your again third option. Moving to question number 6. They say two parallel long wires are given and the carries current I1, I2 and I1 is bigger than I2. When currents are in same direction, the magnetic field between midway is 10 microtesla. When the direction of I2 is reversed, the magnetic field becomes 40 microtesla. What is the current ratio? So watch it. Two wires are given first and they are carrying some current in same direction. Okay, suppose they are placed at some distance of 2x and midpoint at distance of what? X from here and x from here, right? Here magnetic field is given. Current is same initially I1 and I2, then magnetic field is given. So we know that what happens in this case when direction of current is same. What is magnetic field at center? Due to this wire is inward, but that wire is what? Outward. We can know easily direction of field, right? Due to this wire's field is going inward, due to that wire's field what? Outward. Two fields are in opposite direction, means we have to subtract these two fields. Means what is given? Suppose this wire is producing B1, that is producing B2. So in first case what is given? B1 minus B2 is given what? 10 microtesla. This is given to you. In first case when direction of current is same, both are upward or both are downward, doesn't matter. Field becomes what? Subtraction of these two, right now. They are opposite direction field. But they said when I reverse the direction of current here like this way, then now both field become same direction. Look here, this field is inward, that field also become inward. Both fields are in same direction inward, so you can add them, right? B1 plus B2, and this is given what? 40 microtesla to you, correct? Now you can divide this equation. Okay, you see that B1 minus B2 upon B1 plus B2 is equal to what? 1 by 4. Now magnetic field is here, everything is same because magnetic field due to wire is what? Mu naught I upon what? 2 pi r. Constant, distance also same. both wire they asking midpoint, so distance also same. So depends only on what your current, right now. So magnetic field directly proportional current, you can write here current also like I1 minus I2, right, by what, I1 plus what, I2, right, is equal to 1 by 4, cross multiply. So 4 times of I1 minus 4 times of I2 is equal to what, I1 plus I2, right. 3 times of I1 is equal to 5 times of I2. They are asking what is I1 by I2. So this is your answer, 5 by what, 3. So 5 by 3 means this is given in what, in the delta option, fourth option, this answer is given, right. Okay. No. So question number 7 you are talking now. In question number 7 they said that two circular coils are given to us, X and Y having equal number of the turns, carries equal current the same sign, subtend an same angle at point O. Small coil is between O and Y, yes. Okay. So look, yes, very simple question. One big coil is given of radius 2r. They are asking magnetic field at this point O, and that distance is given what, d. Another smaller disc of radius r is placed here on this path. Okay. And that distance is given what, d by 2. So they are asking what's the ratio of magnetic field due to the big Y to what, x. Okay. So magnetic field due to a coil on its axial point is what? What is formula? This is formula mu naught I r square upon what, 2 times of r square plus x square power 3 by 2, right? Yes. So look here, let's write this formula for this ring, okay, big ring, let's call by. What is the answer? Mu naught I, r is given 2r, thus become 4r square divided by 2 times of r square, okay, radius is what, 4r square plus what, d square, power 3 by 2, equation 1, done. Okay, then what is bx, what is magnetic field due to this ring at that point? So watch carefully, mu naught I r square, radius is r, okay, 2 times of r square plus distance, that distance d by 2 square power 3 by 2. Okay, how you can simplify? Mu naught I r square divided by 2 times, if you multiply you get 4 r square plus d square divided by what, 4 power 3 by 2, correct. So let's divide these two equations. When you divide by by bx, look here, this whole term is get cancelled, here 4 remaining, this also get cancelled, so this remaining 8 remaining, so this becomes simply what, 1 by 2, that's all. 1 by 2 means what is the answer? Charlie. This 4 power 3 by 2 means becomes 8, correct na? So this is 4, this is what, 8, keep in mind. Okay, moving to question number what, 8. They said find the net magnetic field due to the given loop at point O. So some loop is given this type of, in form of some sector and straight wire, right, this type, radius given r, okay, yes. So watch here, this is the current flowing and we want to find net magnetic field at this point O. So what is magnetic field due to this wire? 0, due to that wire 0, due to that wire 0, 0. This 4th straight wire has magnetic field 0 because this point along the length of these wires, right now, so no magnetic field is produced. Now these loops only we have, right, correct. So what is magnetic field due to this loop? So you say magnetic field is equal to what, mu naught I upon what, 2r into what, theta by 2 pi. So what is the angle given here? Some theta only given, this angle given theta by 2 pi. This magnetic field will what, inward, correct, into the what. So I can write here some symbol, cross symbol, right. Now we write magnetic field due to that part, same way, this is called as b1, mu naught I upon 2 into radius of this guy becomes what, 2r, right, that radius is what, 2r, and same thing theta upon 2 pi, this field is what, outward, yes, directional current that way, you can grab in your hand, here fingers going inward, down fingers are coming outward, so net field is what, outward. Okay, due to the third part, this part, same formula, mu naught I upon 2r into what, okay, r is how much, 3r into what, theta by what, 2 pi, this field also outward. Two fields are outward and one field is what, inward, so when you add them, you have to add these two and subtract from here, right. Okay, so then you are getting that answer, your first option, okay. Alpha will be the answer, that's given like a 5 by 24 mu naught I theta by what, okay, pi r. So alpha is the answer of that question. Okay, moving to question number 9, and question number 9 says that for a very long straight wire are bound together to form a small cable, currents are given to you, they are asking what is the magnetic field at distance of 10 centimeter. So just a combination of some wires are given and they are carrying what, some currents. Let's find net current. What is net current? Look here, 20 in positive and 18 positive, 12 positive, so this becomes what, 50 minus what, 6 and 7, 13, so net current becomes 37 watt ampere, right now, you have to add all current. Then they are asking magnetic field at some distance, so mu naught I upon 2 pi r, this is a magnetic field due to a wire. Mu naught is 4 pi into 10 power minus 7, current is what, 37 divided by 2 pi, and distance is given as what, 0.1 meter. This goes 2 times, this becomes 74 into 10 power what, minus 6. So this is only the answer, the what, 74 micro Tesla. Delta is your answer, okay, for the given question. Okay, next question number 10 is a cylindrical conductor is given, radius r, carries a current I. So cylindrical object is given, cylinder, this is cylinder, okay, yes, and radius of this is given as r. Then they given the magnetic field at point r by 4 distance inside the surface is what? Some point is given from the surface. Give attention here. This is very simple, but maximum student did this wrong. Distance from surface is given as what? R by 4, that point. But we need distance always from central axis, right now. So what is that small r? Distance from surface is given r by 4, and that total distance what? R. So r minus r by 4 means 3r by 4. So distance from the central axis of the solenoid is what? 3r by 4. Okay, so in calculation you use this value, not that. So at this magnetic field is given to you, okay, how much given? 10 Tesla. So what is formula of magnetic field inside a solenoid? Mu naught I upon 2 pi capital R square into small r. So let's put here mu naught I upon 2 pi r square. What is the distance? 3 by 4 of r goes here, 3 by 8 of mu naught I upon pi into r, and this is given what? 10, equation 1, 10 Tesla. Then look here again, find the value of magnetic field at point which is 4r from the surface, some outside point. Distance again from surface is given here, but we need distance always from central axis, so total distance becomes what? 5r. 4r is from surface only, so that is what r, so 5r. So outside point, what is formula? General formula, mu naught I upon what? 2 pi into what? X. So mu naught I upon 2 pi into x means what? 5r. Mu naught I upon 10 pi, correct na? R. Okay, let's divide these equations. So divide this equation, you see 10, this 10, that's 80, which means what? Obviously 8 by 3, right? Yes. So answer is what? 8 by 3 Tesla. You can replace mu naught pi r value here also here, or you can divide these two equations to get your answer. Okay, this is B1 which is given to us. Okay, so answer comes what? Second option, beta. Okay. So here main was that distances were given like a little opposite order. Distance of outside is given from surface, we need total distance. Inside point is given from the surface given again, we need from central axis always. Okay, yes. Okay, question number 11 says, it says that following the figure shows the path of electron that is passing through two magnetic field, right, B1 and B2, and this moves in a half circular path. Then we have to tell that which field is stronger and what is the direction of the field. Okay, so it's very easy to tell. Look here, this is one magnetic field, then they're showing another magnetic field here. This is B1 and this is B2. It's entering and moving in a small circular path. Then okay, it enters in this magnetic field and moves in what? Big circular path. Okay, look here radius of turn is small, here radius of turn is big, right? In B2 magnetic field, we know that radius is equal to what? mv upon what? qb, constant. So it depends on what? B. Radius and magnetic field are what? Inversely proportional. Strong the magnetic field, small will be the radius. So this radius small, it means what? B1 is what? Greater than what? B2, means B1 is what? Stronger field, right? So radius of turn is what? Small here, that we can see from this formula, correct? Another thing they are asking that what is the direction of the magnetic field here? This magnetic field is inward or outward, okay, that we want to tell. So you can use our hand rule, look here, or if you know right hand rule you can use that. I use vector rule always. So force is equal to what? Q V cross B, right now this is a formula. I am writing vector rule. No, we have to find here direction of the magnetic field, correct na? So watch here, I told you positive charge you can use right hand, negative charge you can what? Use your left hand. So this is left hand I am using. Here I know two things. I know direction of velocity, this is direction of initial velocity, and force is what? Downward. I know direction of force, so I have to find direction of the field, correct na? So what direction of the field? Watch carefully. This thumb shows what? Velocity towards the left, and force, index finger downward. So your magnetic field finger, this finger is what? Straight into the board. Okay, velocity, thumb showing velocity, force I know is downward, is turning downward, so this is a force, so field is what? Into the board. Into the board means correct answer is what here? first option. Okay, alpha is the correct answer. B1 is stronger because you can see radius and magnetic field relation here. Strong the magnetic field, small will be the radius of the current, right? Okay. Moving to question number 12. They said what is magnetic field due to the given loop. So you see that a small arc is given, okay, like this one. Okay, this angle is what, pi by 2. So this is the, okay, I should write dot dot here. This is the loop actually. This angle will be obviously 2 pi minus pi by 2, right? That becomes what, 3 pi by 2, right? And we have to find magnetic field due to what, this loop, correct? So it's very simple. What is magnetic field due to any arc? Mu naught I upon 2 r into theta by 2 pi. Theta is what, 3 pi by 2 divided by what, 2 pi, right? So this much only your answer. What is the answer? So it becomes delta 3 by 8 of mu naught I upon what, pi r. That's your answer. Means your delta option is the correct answer here. Okay. Yes. Question number 13. We are talking a straight section PQ of a circuit lying is along x axis from minus a by 2 to what, a by 2. Some wire is given and is placed what, from minus a by 2 to what, plus a by 2 here. This is a wire, suppose, starting from here and ending what here, carrying some current in some direction. Okay. Yes. Now what is said? The magnetic field due to this wire at point x is equal to plus a. See, they are asking this point. What is the magnetic field due to this wire at this point? So what is the answer? 0. Why? Because this point is along the length of this wire itself, right? This is a wire placed on the board here only, and they are asking magnetic field at this point. So what is the answer? 0. Okay, because this point is along the length of the wire. What is the answer here? Delta. Correct. Question number 14 we are talking. So in question number 14 they are saying that circular coil of radius r carries current, electric current, the magnetic field due to the coil at a point on the axis of the located very okay. Look here, magnetic field due to a circular coil in axial point is what? We have learned just now that mu naught I r square upon 2 times r square plus x square power 3 by 2 is a formula, right? Here they are saying that this distance x point is what, very big than what, your radius of this loop. The point where you finding magnetic field on axis, that's very bigger or very far than what, your radius. So what you do in this term, you can neglect the radius. Sorry, I think opposite is given, correct? No? Yes, correct only. Opposite given. Yes. So look here. Okay, correct only. No. Small r is the distance where you finding. Yes, correct only. So x or the right small r distance. Do not confuse with symbol. Okay, small r is this is your ring. This is the radius r, and this point we calling small r where you want to find the magnetic field, and this point is given very far from the ring. So this r is very big as compared to what, radius of this loop. So I am neglecting this here. When you neglect here, what are you getting? You look mu naught I r square 2 times of r square power 3 by 2 to get cancelled. So it's coming actually r cube proportional, right now 1 by r cube. This much only they are asking, how magnetic field varies with that distance. So r cube proportional. So what is the answer of this question? Delta. Moving to question number what, 15. They said a straight wire of length of the wire is given as what, pi square meter, carries a current of 2 ampere and magnetic field due to this at a point 1 centimeter is, okay. Yes. So what is saying, I have wire, this is a wire length given to you, and they are finding magnetic field at some distance. What distance? This is carrying 2 ampere current, and distance is given as what, 1 centimeter is something that we can calculate easily. Let's call B1 mu naught I upon what, 2 pi r. This is a formula, right? Yes. So mu naught means what, 4 pi into 10 power minus 7. Current is given 2 ampere by 2 pi. Distance is given what, 1 centimeter means what, 10 power minus 2 meter. Okay, this goes here, right? We got 4 into 10 power minus 5 Tesla. That's your magnetic field initially. Now what happened? If the wire is bent into circular, okay, circle and carries the same current, then ratio of magnetic field at the center to the obtained in first case is what? Same wire is turned into a circle of radius, suppose r. Now they are asking what is magnetic field at center. Look here. First, what is radius? This wire of length pi square is turned into a circular loop of length what, 2 pi r, right? Length of the wire L is turned into a loop of what length, 2 pi r, right? Circumference is 2 pi r. So pi you can cancel here. Radius is actually what, pi by 2. This is the radius, correct? Now what is magnetic field due to a circular loop? You know, mu naught I upon what, 2 r. Mu naught means 4 pi into 10 power minus 7. Current is 2 ampere only. 2 into radius is given what, pi by what, 2. This 2 get cancelled, pi get cancelled, getting 8 into 10 power minus 7 Tesla. This we getting right. So they are asking what is the magnetic field in this case to first case, means 8 into 10 power minus 7 in this case divided first case how much, 4 into 10 power minus 5, correct. Okay, so you can simplify this. Okay, so it become 2 and send this one to become 100, so you can write 1 by 50 or ratio 1 ratio as 50 is the answer. Okay, so this is given in your beta option. Okay, moving to question number 16, and they said that a vertical wire is kept in xz plane, carries a current Q to P, magnetic field due to current will have the direction at origin O. Okay, so some coordinates are given. Look at the coordinates how they are given. So this direction is given as what, x here, and that direction is given as z, and this is given y dash, and inside direction is given as what, y only, right. Wire is placed here, this is a PQ wire. Okay, current is flowing upward. They are asking what is the magnetic field due to this at that point O. So it's very simple to see. You grab this wire in your hand, on this side fingers goes inward, on this side fingers will come straight outward when you grab in your hand, right. Fingers coming outward is what, that direction O y dash, right now. So O y dash is the answer, O y dash outward. So this is given what in your delta option. Moving to question number 17, they say 1 meter length of wire has a constant current. The wire is bent into circular loop. The magnetic field at center is B. Now same wire is bent into circular loop of smaller radius having 4 turns. So for this I have already discussed a shortcut with you. One loop you have radius R, magnetic field at center is B. Now this loop is turned into smaller loop, n number of turns of small radius R. Then what happened to magnetic field? So magnetic field B dash becomes what, n square times of the B, correct now. One loop you turn into n number of loops, then what is magnetic field? It's increased by what, n square times. So they said one loop was there, I turning into 4 smaller loop. So B dash becomes what, n square means 16 times of the original B. So magnetic field will be increased by what, 16 times. Means what is the correct answer? Beta is the correct answer. Question number 18 we are moving. So in a hydrogen atom, they said an electron moves in a circular orbit of radius given, produces a magnetic field given to you. They are asking what is current produced by this electron. So very simple question, magnetic field due to moving charge is what, mu naught I upon what, 2R. This formula only, all are given to us. We have to find current. Current is what, B into 2R by what, mu naught. Let's put the values. Magnetic field is given to us as what, 12.56 Tesla. 2 times radius is also given to us how much, 5.2 into 10 power what, minus 11 meter, divided by what, mu naught means 4 pi into 10 power minus 7. This directly goes here because 4 pi is what, 12 point something, this is 12 point something. So this become 10.4. So 10.4 into 10 power what, minus 4 is remaining. So this answer you can write how, yes, return 1.04 into 10 power minus 3 ampere. Delta is the answer for this question. Question number 19 we are talking now. Okay, so proton is moving with a constant velocity, passes through region of space without changing its velocity. Velocity not changing, electric and magnetic field represent the electric. Okay, then what can have? So I told you two possibilities. Remember, a charge is moving in both electric and magnetic field, then it moves in a straight line. Suppose if electric field, magnetic field and velocity all are perpendicular to each other, then it moves in a straight line at constant speed and constant velocity also say, right now. If they are parallel to each other, electric field, magnetic parallel, that they are all are parallel, then again charge moves in a straight line but speed will be varying. Okay, speed will change. So this is a possibility, like when they all are perpendicular, then what happens? It moves at constant speed and in straight line, right now. So they're saying when this can happen, here electric and magnetic field both are there, still is moving in a straight line at constant velocity. So electric may not be 0, magnetic also may not be 0, still the charge can moves in a straight line. Okay, and it comes with constant velocity. So what is the answer of this question? Delta. 20th question. A uniform electric and uniform magnetic field are produced pointing in the same direction. The electron is projected with its velocity pointing same direction. Electric field given, this is direction of electric field suppose, and this is direction of magnetic field. They are in same direction. Now what happens? Electron is fired in the same direction. They are asking what happened to the velocity of the electron. Electric field in this direction means what? Positive charge on this side and negative charge on this side, right? Electric field starts from positive and goes to negative. Electron you firing here means this is a negative, that's also negative, it will so we fire electron along the direction of electric field, then what will its velocity will reduce. Why? Because negative, that's negative repulsion will happen. So velocity will be what? Reduce. Correct? Yes. So what is the answer of this question? Velocity of the electron will decrease in magnitude. What is the answer? Delta. Okay. So this is the review of your quiz. If you have any doubt, please put in your comment. Thank you so much for the watching. Have a good day.